Hi, I'm Sam Boone, and today I'll be talking to you about the dual AusGeochem and LithoSurfer global geochemistry data platforms and their application for big data and low temperature thermochronology. So as you're all well aware, over the past decades, the geosciences have undergone a radical transformation in the quantity and quality of data that are being produced by laboratories. This is particularly true since the advent of various in situ analytical techniques, the integration of multiple analytical instruments to do simultaneous double and triple dating, for example, the advent of new geochemistry techniques such as laser-induced breakdown spectroscopy, and more sophisticated and robust ways of performing digital image analyses, which are particularly relevant to the fission track technique. Now, with the advent of new and exciting ways to generate lots and lots of data at an ever more rapid pace, come new challenges. And first and foremost is that actually relatively few of these data ever make it into the public domain. At Tango 2018, this is an annual meeting of geochemists and geochronologists and thermochronologists from across Australia. It was estimated that a mere 5 to 10% of Australian geochemistry data, or Australian produced geochemistry data, ever make it into the public domain. And even those data that do make it to the public domain are often reported in varying degrees of detail and are generally unstructured, making it quite difficult to actually compare published data from different studies. And even then, there's such a wealth of data and a wide variety of data that it's becoming increasingly difficult to actually synthesize these data and extract meaningful interpretations. And thus, new tools and new techniques are required to actually deal with these big data. So in 2019, a new organization was founded called the AusGeochem Network, or AGN. This is an Australian funded organization of geochemists from across Australia, based at 3 nodes: Curtin University in Perth, the University of Melbourne, and Macquarie University in Sydney. And we set out to explicitly address some of these data transparency and big data syntheses challenges. And we're working with geochemists and data scientists from a wide range of institutions across Australia. And the idea is by pooling our expertise and our resources and our data that we can both promote Australian geochemistry research while then making those data and that Australian produced science more visible to the wider world. So the chief mechanism by which we aim to accomplish some of these goals and tackle some of these challenges is the development of AusGeochem, an open cloud-based geochemistry data platform explicitly designed to service the Australian geochemistry community by making Australian-produced geochemistry data from around the globe more accessible to the wider geochemistry community globally. And to do this, we've enlisted the help of Lithodat, a Melbourne-based company of geochemists, software engineers, and data scientists, who too are building their own geochemistry data platform called LithoSurfer, which is, by contrast, designed to then service the wider global geochemistry community. Now, both of these share the same core model and serve very similar functions, simultaneously acting as a sample registry, allowing laboratories and analysts to database and archive their geosamples and associated geochemistry data. They serve as data repositories, allowing people to then archive the data that they produce. They can disseminate those data to colleagues of their choosing while maintaining privacy control, essentially giving them access to the data within the platform, which they can then play with and manipulate and visualize in different ways. And then you can eventually, if you choose, then make those data available to the wider public, essentially publicizing those data sets. And lastly, it also serves as an active research tool, an analytical tool. Once the detailed data are within the structured AusGeochem LithoSurfer database, you're then able to then do a wide range of statistical analyses, including on-the-fly recalculation of ages and things using different parameters. You can mine data that's already in the database, so you can view your data within the context of other studies and research. And then there's a number of built-in functionalities to synthesize and visualize those data. And at the end, you can export the data of your choosing, as well as the various plots, figures, and maps that you've generated in the platform. So while AusGeochem and LithoSurfer can kind of be thought of as two sides to one coin, there are some slight differences. As I mentioned before, AusGeochem is explicitly designed to service the Australian geochemistry community. And in the future, we also hope to get certification to become a data repository in its own right, so that you can actually publish those data sets and get citable DOIs. Now, all of the data that is archived within AusGeochem is also available in LithoSurfer. Now, LithoSurfer is basically designed to then now service the global geochemistry community, as I mentioned. And it has a few other functionalities, including some additional soft data features, such as data models for digitized thermal history models, as well as some pretty exciting and interesting things like space tech, which a module called LithoSpace that allows the visualization archiving of geochemistry data from extraterrestrial bodies. Now, there are a number of current data models under development for both of these platforms. These are shrimp uranium lead, laser ablation uranium lead, and lutetium hafnium, argon argon. And probably the next cabs off the rank would be then to add laser ablation, rubidium strontium, and samarium neodymium models, as well as data models for major and trace element geochemistry. But there are three other models that are currently under development, and which the rest of this talk will focus on. And those are the fission track, uranium, thorium, samarium, helium models, and this data model for the digitized thermal history modeling results. Now, to build the data models and data schema for these three low temperature thermochronology data models, a group of low temperature thermochronologists from across Australia have been assembled that include Martin Danisic from Curtin in Perth, Stijn from Adelaide University, Renjie from UQ, Barry Cullen and myself from the University of Melbourne, and Fabian Coleman from Lithodat. And what we've done is we've designed data models in line with established international best data reporting practices, and taking on board lessons learned from the development of the two GSA bulletin papers that are underway, one for fission track and one for helium analyses, of which we have representatives from this advisory group that are involved in both of these publications being developed. Now, these data models include fields for the analytical metadata, including calibration parameters, detailed analyses on a per grain and per track and even semi-track basis, crystallographic dimensions and morphologies, kinetic parameters, including major and trace element geochemistry pertinent for these methods, reference material results, and associated errors. Now, for the thermal history model data schema, not only do we have the thermal history model results, but the data schema includes fields for the modeling metadata, input parameters, the kinetic models employed, the time temperature constraints used, the resulting predicted data in the case of inverse models, and the goodness of fit, so that the quality of these models can be independently assessed. Now, once the data models were developed, then our next job was to actually define the relationships between these various fields. And it's this structured relational database architecture that provides the LithoSurfer and AusGeochem platforms with these really powerful on-the-fly data analytical functionalities, which I'll show you in a moment. Now, in order for these data models and the platforms to work their best, we need to collate a huge amount of data, which we want to make as streamlined and as streamlined and easy as possible, essentially. So people can upload the data into the platforms via the built-in user interface that allows simple drag and drop of CSV files into the database. But also there's more sophisticated ways in which users can interact with the platforms, and that is via the platform application programming interface, or API. Essentially, this allows developers or anyone with some simple coding capabilities to then write scripts that can then allow their software to interact with the AusGeochem or LithoSurfer database. So one of the most useful ways in which these could be employed would be essentially writing scripts that would auto-upload exported data straight off of the analytical software into the AusGeochem and LithoSurfer database. And from there, it can then be shared to collaborators into the publication domain, made widely available simply by changing the privacy settings.
So here I'll give you a quick demonstration. This is LithoSurfer, but AusGeochem works just the same. So you can explore the database in its geospatial context by scrolling around. It operates similar to how Google Earth does. You see here we've just changed the base map from satellite view to street map, but we also have other types of base maps, including geology and dark. Now, if you'd seen, I've just hovered my cursor over a sample. Some small amount of information, like sample name, comes up, but when I click on it, I can find out additional information about the sample, the associated data, and here we're looking at a range of appetite fission track analyses from around Sydney in Eastern Australia. Now, by clicking on the reference, it takes you straight to the associated publication, where you can find out more about the study. So one of the most powerful and exciting features within the AusGeochem and LithoSurfer platforms is the ability to do cross-data analytics on the fly. And here we're drawing a polygon over a number of appetite fission track analyses from southeastern Australia. And you can see here that LithoSurfer is doing some on-the-fly calculations and produces a number of nice figures. Here we're looking at appetite fission track age versus mean track length, or a boomerang plot. We can go up and look at age versus elevation. And there's also age histograms. And you can see that you can actually adjust the axes on the fly within the platform. And so this is quite a powerful tool, and then you can export these plots at publication quality standards and plug them straight into your manuscripts, which is quite handy. So scroll up a bit further towards Sydney and Newcastle. You can see that we can turn on other types of data, because of course AusGeochem and LithoSurfer not only house low temperature thermochronology data, but a range of geochemistry and geochronological techniques. And again, here we're drawing another polygon in the Penrith area of not only appetite fission track data, but a number of geochronometers. And again, LithoSurfer is making some calculations, comparing these data and producing some plots. And again, so here we'll look at age versus elevation. And what you'll see is that the color of the plots actually are associated or relate to the type of data.
In addition to some of the various ways in which users can interact with the data within the platforms, as I've just demonstrated, LithoSurfer has the additional capability of allowing users to interact with digitized thermal history models. So here, for example, we're looking at a number of digitized thermal histories from the Xinjiang in Central Asia, from Stijn and his group. And this tool allows you to choose the time period of interest. So here we're looking at 100 million years ago, and on the fly can calculate how what the cooling and heating rates are as extracted from these digitized thermal history models. And once the data, all these various low temperature thermochronology data are archived in a structured way in the relational database, one of the real strengths of these tools is that it allows data that was generated using different parameters and perhaps reported at different times to be equated and compared across regional or global scales, because the relationships between these different parameters and different age equations have been defined within the database. This data can then also be compared to other types of data, excuse me, including heat flow or thermal conductivity or other geochronology and geochemistry data. Now, one of the really exciting aspects of this work, in my opinion, is the fact that because we require people to upload reference material results along with their unknown analyses, over time, we'll start collating an enormous amount of reference material results across many laboratories, enabling new inter- and intra-laboratory comparisons to be performed on a scale previously unavailable. So this will allow us to visualize things such as, how well are multiple labs or various labs doing on a particular reference material, or how is an individual laboratory doing over time with one individual reference material, say, and what does that distribution of ages look like? And we can then in the future perhaps incorporate other ways of visualizing these sorts of reference material data, such as steam graphs, which could be an interesting way to visualize how precision is changing over time. Now, to populate the AusGeochem and LithoSurfer database, the expert advisory group and Lithodat have been hard at work at digitizing huge numbers of low temperature thermochronology data. including large and scientifically important legacy data sets, such as this one here from Kohn et al. In 2002, which consists of on the order of 2,700 appetite fission track analyses from across Australia. And already we have nearly 30,000 low temperature thermochronology data archived in the database from around the world. Now, if you want to learn more about the development of these platforms and our progress, about the AGN or AusGeochem or LithoSurfer and Lithodat, I encourage you to visit their respective websites. And you can also see other webinars that are recorded on a monthly basis from the AGN at the AGN YouTube channel. So I'll be happy to field your questions now, and feel free to reach out if you want to inquire about something or discuss this work further by contacting me directly. Thank you very much.